Welcome to another edition of Comet Algebra. This video is for Algebra 1, Chapter 2, Section 5, Solving Two-Step Equations. First, couple definitions. You need to know that an equation is a mathematical sentence stating that two expressions are equal. A simple way to say this is that an equation has an equal sign. An expression does not. So you do need to know the difference between an expression and an equation. An inverse operation is an operation that will reverse or undo a given operation. And we need to know that adding and subtracting are inverses of one another, and multiplying and dividing are inverses. And that's what we'll be using in our undoing method. Later on, you'll learn that the opposite or the inverse of squaring the x would be to take the square root of both sides. And we'll keep adding to your skills of undoing method to undo the same thing to both sides, which is written here with some stars, so you know it's important. You must do the same operation to both sides of an equation to keep the balance. If you don't do the same thing to both sides, you have destroyed the equal sign. Think of it like a teeter-totter. It's balanced. If you add something to one side, you must add the same thing to the other side. The other notes here is I want you to think about doing PEMDAS backwards when you decide what operation to undo first. So it may help to write PEMDAS this way. And when you're doing the undoing method, you start at the bottom here and we work our way up. So the first thing that we undo typically is adding and subtracting. And then the second thing we undo is multiplying and dividing, because we're doing PEMDAS backwards. All right, let's look at a couple examples. In this first example, I'd like to go through the thought process. If you put your pencil on the letter X and ask yourself, what is being done to the letter X? Right now we are multiplying by 7 and adding a 27. So like I said, we're doing PEMDAS backwards, so we're going to start by undoing this addition. And we're going to subtract a 27 from both sides. And subtracting here, we would get 21. And then we are multiplying by 7, so we do the opposite of that, and we divide by 7 on both sides to get our answer of 3. The next example, again, I'll go through the thought process. The letter Y is being multiplied by 2, and then we're subtracting 16. So PEMDAS backwards, we start by adding a 16 to both sides. And we'd get a 6. We're timesing by 2, so we divide by 2 to end up with Y is 3. And I would like you to show your work. Show what you're doing to both sides of the equation. We're learning this process, and so for right now it's important that we show our work, learn this undoing method well, because you'll be using it in chemistry, you'll use this balancing chemical equations, you'll use it in all your math and science classes. All right, here we have the letter X. We're dividing by 8 and subtracting a 9. So we start by adding a 9 to both sides. And then I get X divided by 8 is 3. Since I'm dividing by 8, I want to multiply by 8, and it may be helpful for you to write the 8 over 1 because we have this fraction here, and that might help us see that we're multiplying by 8 in the numerator. And then this side we're just multiplying by 8. Here, X times 8 divided by 8, you can think of it as canceling. The 8's cancel, so we are left with X equals 24. All right, in this next example, again, we start with the adding. and we would subtract a 39 from both sides. And that would leave us with 4b is equal to 24. And then, of course, we divide both sides by 4 and get b is 6. Here we're dividing by 12 and adding 15, so we start by subtracting 15 from both sides. We get x over 12 equals 3. Then we multiply both sides by 12 to get x equals 36. Okay. Now in the example number 6, we have a couple choices here. We have the x is being multiplied by 2 and divided by 9. You can do those separately. You could multiply 9 on both sides and get and 2x equals that answer, and then divide by 2. But I'd like you to also learn a method. When you have this x and it's being multiplied by 2/9, we can do this all in one step if we multiply both sides by the reciprocal. So the reciprocal of 2/9 is 9/2. I'm going to put this 36 over 1 just to make it clear, and then multiply this side also by 9/2. And you can see what happens over here. The 9's cancel into 1's, the 2's cancel into 1's, and we're left with x. And then if we come over here, I can divide the 2 out. 2 goes into itself once. 2 goes into 36 18 times. And then if I multiplied correctly, I ended up with 18 times 9 is 162. So make sure you check my math, but I think that's right. Okay, now in this, I think this is our last example. Yes, it is. We have, there we go, something a little different. We have to take a look at this numerator. We have x minus 7. This is an exception to the rule about following PEMDAS backwards, but for a very good reason. When you have a numerator, you can't break it apart by adding a 7 to both sides. This is a numerator. I like you to add parentheses here, because then that helps us. This is kind of our thinking part over here. We're thinking about PEMDAS backwards, adding and subtracting down here at the bottom. What we have in this problem, we have some parentheses and we have division. So if we're coming up from the bottom to PEMDAS, we have to take care of this division first, and then we'll work our way up and we'll take care of the parentheses last. So this is true when you have a numerator or denominator with x plus something or x minus something. So we're going to start by multiplying both sides by 3 this time. The 3's cancel. Now that x minus 7 is no longer a numerator, you can remove the parentheses. And so our last step this time would be to add a 7 to both sides. And then we'd get 22. So once again, when you have this numerator, you need to put it in parentheses. All right, I think you have all the knowledge you need to do section 2.5, so have fun with that.